Is it say recording? Good. All right, we've got a whole lot of things that we need to accomplish, and we don't have a whole lot of time. I'm wondering why I only see 4 people with the unit guide out already. This is your thing we're going to use every single day for the entire course. It comes with you every single day. You just need to have it out. You also want to take out your calculator. While we're in the business of taking things out, please have the summer assignment round 3 in the middle of the table, as well as your assigned syllabus in the middle of the table. I'm going to get all that taken care of. Can I get somebody who'd be willing to be the paper picker upper? You have to be well trained. Kevin, you got this? Kevin, you have experience picking up papers. We will see. Kevin, paper picker upper, you're going to go around, you're going to pick all the things up. If they don't have their name on it, don't take it from them. I want to learn from period 2. Period 2, I have a random pile of papers. I have no idea who they belong to. Kevin, if there's not a name on it, don't take it. No. With the syllabus, you've signed it. Therefore, your name is there. Just give me the back page. Give me the back page. Thank you guys for asking all the right questions. So that's summer assignment round 3. Things that I want you to know. Panic is about to settle in. You have your first calculus quiz tomorrow. Breathe, Jackie. Everyone's like, oh my God, I need to drop the class now. It's day 3. No, tomorrow's day 4. Okay, so here's what the quiz is. It is 10 limit questions. Hold on. Since the only thing we've talked about is limits, you should be expecting it. 10 limit questions. All of them are about parent functions. Meaning, I need you to know all those parent functions. So yesterday, if you guys remember at the very beginning of class, it was like on assignment, it was like lesson 2. There were like 10 parent functions, and I asked you about limits, and some of them we said does not exist. There's 3 reasons why a limit would not exist. Anybody remember any of them? Great, give me one, Jackie. Oscillation. Oscillation means wiggling. Wiggling at the ends is one reason. Give me another one, Delia. Unbounded behavior. You have a limit going to infinity or negative infinity. That's 2. There's a third one. There's a third one. There's a third one. Evelyn's smiling at me so nicely. Evelyn, what's the third one?
The limits don't equal each other?
The limits don't equal each other. Specifically, though, the limit from the left and the limit from the right are not equal to each other. This is part of the problem. Are we good? It's going to be 10 questions, 5 minutes. It's only parent functions. Last class asked, oh, so is it matching? No. I'm just going to say, what's this limit? And you need to know. You need to know the parent function. You need to know the end behavior. And you need to know what to write. Okay? All right. Other things that you need to know. Friday, we're going to be doing a calculator check, which should not be a problem because everybody in the room has a calculator. Some of you have calculators that are blinking because it's in press to test mode. Tomorrow I'll be available during lunch and we'll get these things out of press to test mode. If anybody's still in press to test mode because it is draining your battery. Okay? If you need to charge your calculator, you probably want to do that right now. Tonight's homework. Please write this down. It's in the unit guide. Good news. All the homework is going to be in the unit guide. Carlos, are you okay? Are you sure? You are surrounded by beautiful women. You're like Steve Trevor in Wonder Woman on Paradise Island. Step up, man! Okay. Page 58, all the problems. It's like 8 problems total. Question number 4 is the only one that you can use your calculator for. Question number 4 is calculator active. That's the only one that's calculator active. Naomi, you good with that? All right. All right. And if you did not turn in an assignment on time, and you didn't stop by and talk to me, a little bit of public shaming is coming your way. All right, I am missing assignments, parts 1 and part 2 from Juan, Ivan, we just spoke, and Carlos. You need to get this taken care of. And missing email, Juan, where'd my Juan go? Juan, hello. You're gonna live on the naughty list this year, aren't you? I might rename it the Juan list. We're gonna call it pulling a Juan. Okay, Juan is on the naughty list. Ivan is on the email naughty list, but he told me why. Jose is on the naughty list for the email, and where's Jose? Jose, we're gonna get this taken care of? Like today? Yeah, good. Because everybody else was emailed solutions to the problems that we're gonna do in class today that are gonna help you on the homework, but Ivan didn't get it, and Jose didn't get it, and, well, Juan. Let's be real. You didn't get it either because I don't have your email. That's how it works. All right, and Kevin, just so that you know, I know you said you were well trained. I clearly need to do more training. There's a yellow folder on my desk that says to be graded. If you could put that in the brown leather bag, that's what you get after working 10 years at Yes Prep. I got that bag 10 years ago. No, it's not time for another one. It's time for something better. I'm thinking like a Yes Prep car. Like a nice one. Alright, so here's what I want to do. I want to give you guys a little bit of time to show me what you got on your calculator skills. You're looking on page 8. So we're at the top of page 8. And this is different from what's in the handout, and that's okay. I'm well trained. I can do these things. Evelyn, have faith. So, I want to give you guys a couple minutes. Use your calculator. There's some stuff here that I want you to see. The first one is the limit as x approaches infinity, 2x squared plus 3 over 3x squared minus 5. Absolutely use the calculator. Next one, limit as x approaches 0, 2x squared plus 3 over 3x squared minus 5. We'll talk in about 4 minutes. Yep. Is your calculator like dead? I'm sorry. Thank you for that, Jose. Thank you for making me a better teacher. Okay, Jose. Okay. So the first part, get an 80. The second part, get my grade. Monday, highest grade. Evelyn. Okay. Section 1 is looking good. Are you going to turn the page 8? You're going here? Okay, so section 1 you get a 9. Section 2 you get a complete, which means that is not a grade in my grade, but you have no time, okay, to get these taken care of. The highest grade is going to be on the 7. Ashley, you probably heard everything. Okay. Section 1, the assignment you get 7. Section 2 is not a grade, my grade, right? I'm not trying to be anything, I'm just trying to figure out who you are as a student and how much extra support, how many times we're going to teach you. AP class. I have a really high expectation for you. You're going to meet them. I know. Okay. Friends over here, how are we Okay, for anybody who's on a little bit of the struggle bus right now with what a good way to do this would be, right? You graphed the function on your calculator already, and you're going to build a table of values. Maybe you want to use the trace feature, maybe you want to go to the table. Either way, it's fine with me. But if I'm going to be approaching infinity, I need to be picking numbers that are getting close to infinity, for example. A good starting point? Maybe a good starting point is like 10. Right? Not infinity, but it's a good starting point. Another number to pick? Maybe 100. What else? 1,000. What else? 10,000, right? I want to get big. And how far do you have to go? How do you know when you have arrived at the answer? There's something specific I'm looking for here. You're looking for stabilization. The stabilization I'm looking for just means like, hey, the numbers have stopped changing. Specifically, I'm looking for the first 3 places after the decimal. Your calculator is doing all the hard work, but what I want to see is I want to see that table of values written down on your paper. Here are my inputs. Here are the outputs. Get about 1 more minute. Nice. Nice. How are we doing? Good. How are we doing?
How do I make it go to?
Oh, you're doing this one? Okay. Fine.
All
right. So I am seeing on several papers. For the first one, take the limit as x approaches infinity, and we're getting 0.666. How many of you guys have 0.666? I'll also take 0.667. Right? It's a rounding thing, so that's great. So what I'm seeing is that as your x's are approaching infinity, your outputs are converging, or they're approaching to 0.666. I'll take 0.667. Everything is great. Now here's what I saw in somebody else's paper for limit as x approaches 0. And maybe you didn't get there yet, and that's okay. I can deal with that. I'm seeing 1, 0.1, 0.01, 0.001, 0.0001, and we seem to be stabilizing at negative 0.6. How many of you guys are getting negative 0.6? Okay, 1 person, maybe 2 people. Okay, here's the problem though. I have a problem. We have a problem. We have a problem here. If you are telling me, based on this work, that the limit as x approaches 0 is negative 0.6, we have a problem, and I'm wondering if anybody sees what the problem is. Kaylin sees it, Kevin sees it, Ivan sees it. Kaylin, what do you see? Did everybody hear what she just said? Right, the issue is, what side of 0 am I approaching from? Both sides. I need the left and the right. What this student did, the 1, the 0.1, the 0.01, they're only approaching it from the right-hand side. So what I'm looking for in an ideal answer is that you're going to also have another table with things like -1, -0.1, -0.001, and I'll tell you, you're also going to stabilize to negative 0.600. And so what's the final answer for the limit? Negative 0.600. Don't do something crazy like round and say -1. We look for the stabilization because this is what the answer is. Eric, are we okay in the back?
Yes.
I'm just trying to make sure I use the names of all the people that I don't know yet. Everybody's good? Okay, I'm curious. How many of you all knew 0.667 was going to be the answer to this first one? Before you picked up a calculator, before you did anything. Maybe there's something you remember from back in the day with Mr. Lincoln pre-calculus. What do you think, Carlos?
I don't want to. say it.
It's okay, I will not throw a marker at you.
Okay. Is it a symbol?
Is it what?
Or like a symbol like pi?
It's not gonna be a symbol like pi. There is something that you guys would have done last year with Mr. Link that made problems like this really quick and easy. Jose, what do you remember?
The plus and minus.
What about the plus and minus?
When you had together you could factor them out. But you plus and minus and you could cancel something out.
Not quite. Not quite. Yeah.
Is it about the x? Say the bottom one is bigger. I think you can divide it.
There's something to do with the exponents here. There's something going on with the exponents here. It specifically has to do with the fact that what's the biggest exponent in the numerator? 2. This is the degree. This is a degree 2 polynomial, and in the bottom, in the denominator, another degree 2 polynomial. There was something that you guys did last year when there was a tie. The degree in the numerator, the degree in the denominator is the same, or some of the cobwebs, maybe you can clear it off now.
Yeah.
There's something that you're supposed to do. You look at the coefficients is what I just heard. The limit would be 2/3. Anybody know the decimal name for 2/3?
0.667.
0.666, 0.667 if you're not sure how to find a 6th grader. Okay? That was weird. Sorry. We're kind of okay? I was not necessarily expecting anybody was going to remember this. I wanted to make sure we could all do this on the calculator. Okay, limit as x approaches 0. There's another thing. God, Mr. Link taught so many things. There's another thing that he taught you about limits. That might get you an answer very quickly. What if you plug it in? What happens if you plug in 0? You get 0 plus 3 over 0 minus 5, which is negative 3/5. Anybody happen to know that? Negative 0.6. Yep. For the teachers watching at home, that was the Explorer. Okay? So you guys had an opportunity to figure out the answer on the calculator, and I think for the most part, calculator, we're good. Looking for stabilization in 3 decimal places. We're going to put the calculator away for the rest of the day, because what I want to do is I want to focus more on all that work Mr. Link did with you last year. We're specifically going to work on these problems at the bottom of page 8. Juan, if you wouldn't mind passing these out to everybody. I didn't leave you guys enough room to work. That's going to be okay. Ivan, I'm going to move over here to this board. You make sure that I'm looking good over there. Can people see me? Yes. All right. So let's take a look at this. I want to look at problem number 1. If you want to do it on a separate sheet of paper, that's a good thing. What I want to focus on today, we've only got about 15 minutes left, so I want to use this time wisely. Is I want to focus on these limits that are going to require algebraic manipulation or algebraic trickery. Yes, sir. You're going to want to keep it handy. Okay. One of the things I know from having taught calculus for a very long time now, since while you guys were in elementary school, is that this first unit gets really tricky for a lot of folks, and they get like all turned around because students look at a problem like this and they don't actually know what to do. Like, they know how to read it. They're going to say it's the limit as h approaches 0 of all this stuff. But then they don't know what to do. Hold on, Jackie. Some folks are going to say, gosh, do I know what this graph looks like? No, this is not a parent function. Some folks might say, what else could we do? If you knew what the graph looked like, you could do that. What else? Maybe there's some formulas, but